So I guess for this part, I'll stay sitting at my desk. Chris, do you want to sit back there? Can you see it from there?
Yeah, I'm good.
C4?
Huh. Boom, boom, bang. Yes, sir.
All right. Okay, so what I'm going to be covering is essentially what something you can do in an hour or two right after doing the original tutorial in the Rust language. So this kind of goes off the screen, but if you want to go find me on GitHub, I'm Tekadan. So as you can see right here. And then Rust-Hangman with Dan is the URL if you want to pull this down, clone it, however you do your GitHub. Then once you're there, you have to install the Rust kind of command prompt plugin, I'll call it. Same way you would use Git from the command line, and that's how you compile, build, and run your applications. The only prereq I do recommend is the guessing game tutorial online. It's a really nice, short, it kind of holds your hands, introduces you to the basics. A lot of that I've either pulled into this or acted upon. So that's kind of where I got the whole idea of doing this. And I modified it. And what's cool about this is it uses strings, which are very confusing in Rust, as you'll see, but it makes you more comfortable with them. So it gives you kind of a small block instead of saying, I'm going to do this crazy thing, I'm going to make a fun little game that you can play with like a 5-year-old and be proud of. Things that are nice to have, so be comfortable with Git if you want to pull it down, or Google. You can literally just say, how do I? And Stack Overflow will have some answer with 2,000 like or positive votes, and that's how you do it. And the understanding of strings really helps, just because this is pretty string heavy. Since it is Hangman, you are comparing strings, you're inserting, you're removing, you're creating, you're transforming. With that being said, this is, as of right now, exactly how I have it on my computer. I might refactor it, but as of right now, it's working. You should be able to pull it down and run it. Change the secret Hangman password thing, but we'll get to that in a bit. So the first thing I want to introduce is a couple things that are the semantics of the language. And I call it skeleton.rs, so your Rust files are .rs extension. That's a bit of the project. When I actually compile, build, and run it, I'll show you what the whole project looks like. What's covered is we have variables, strings, loops, conditionals, reading input functions, and that's the broad things. We have a couple niche things that might help us do a particular line, but that's really what we're going to be learning about here. So as you can see, in our game, we have this main function up here that we're going to be having. It's called myGame. So one thing to notice, all functions are declared FN. That's kind of JavaScripty, if you remember. So you have, I declare function. This is the name of my function. You have your parameters here, and then your return type. So the dash bool means I'm returning a truthy statement from this. Regular curly braces, you have your start, my end's down here, and then I'm calling other methods in here. I have a loop, and then I have a couple methods down below. So the first method I'll be setting up is initGame. So set your couple things. How many guesses is the person going to get? What's the secret word? Get kind of the behind the scenes that don't need the user set up. After that, we start our game loop. So if you develop a game, whether it's a first-person shooter, an a role-playing game, a chess game, any kind of game really runs on a loop that says, did you win, did you lose the game, and it keeps iterating through. It gets crazy when you're trying to maintain frames per second. Thankfully, we're not doing that. We have nothing graphics-wise we're doing. So how our loop will go is we'll output, how's the user doing? How's the player doing? What round is it? How many guesses you got left? How's the world looking? Next, we'll prompt and collect the guess from the user. So that's your very simple, how old are you? I'm 23. And you hit enter and it says, hello, Dan, you're 23. That sort of exercise. We'll evaluate the guess. So in part of the collection, we're going to validate that the answer, or that the input is well-formed, and then we're actually going to evaluate it and compare it to our solution and see if it's correct. Then from there, we'll have our terminating condition. So you saw that it's a while loop. So right off the bat, Rust doesn't have a do while loop, so we'll have to manually manage this down here. And they'll just simply be a couple conditionals with a break. So down here we'll either figure out, did you lose? Okay, break. Did you win? Break. Otherwise, keep going through the loop. And then finally, we'll display the end results. So when we do that, it's, hey, you won. Hey, you lost. Here's a word. And then finally, down below, I just have all of my methods. So I'll kind of give you a glance. And the reason I included these is so this would actually compile if you built the project. So that way, if you pull it down, you can kind of see. Obviously, these aren't real code. So in a game, this is supposed to like return the number of guesses you have, 42 for the Hitchhiker's Guide to the Galaxy. Output game state, you're doing great. So as you can see, the functions are pretty simple. It's function, name. So the naming convention in almost everything is all lowercase, no camel case, and just separated by underscores.
Called snake case.
Snake case. And it gives you warnings in your compiler by default if you're not following that case. So it's kind of cool. It has a best practice built into it. As you can see, the return type is string. There's a couple different types of string. There's lowercase str. There's also uppercase string. If we have time, we can kind of go into detail on that and the pros and cons. This one I found is much easier to work with than the other one if you're new to it. And this is also mainly what they use in the guessing game tutorial. So if you're coming from that, you'll be familiar with this one. Return statements are just like almost every other language. The only exception is instead of just being able to pass a string literal back, as you can see this is string, I actually have to call .toString on it, which kind of boxes it if it was an object in a different language and makes it so we can return it in a string collection. As you can see, we have a couple different types. We have characters, booleans. Up here, this is an unsigned int if we're in other managed languages. So that would be what? uint if we were doing C#, which most of us are familiar with. You also have i32, which is a positive negative integer. But you don't just straight up have int. So that's one thing to be aware of. So at this point, that's kind of be the logic of our game. So we're going to start it. We're going to go enter a loop that manages player state, prompts them for some stuff, does our business logic, and then displays the end results at the end of it. Does anyone have any questions on that so far? Pretty simple. If you've ever written a game, you should be good. If not, hopefully we can write one together. Okay, so things are going to start getting crazy. I didn't segment this out, but I'm going to kind of go down linearly how we were. So there's one thing to notice here, or two things I'll say. So the only thing that you need in your Rust applications is main. So this is very reminiscent of almost every console-based application you'll ever write. There's going to be some main function. That's where it starts. In most languages, that's a static. This is not static, so that's kind of cool. It also can have a return type. Found that one out. Most languages, it returns an int or a boolean. Most, like in C, I know it returns like a 1 if it passed, 0 if it errored out, or custom, which is kind of cool. But this, you just leave it as is. One thing I do have at the top is use standard I/O. This is what allows us to read from the keyboard. We'll get into that later. That's explained really well in the guessing game tutorial. So all I do is I say let game result bool game loop. So this is a lot different than what you've seen so far. But essentially what it says is it says let declares that we're about to have a variable. Game result is the name of our variable. As you can see, it's a snake case. The type, so instead of having the type in front of the variable like you do in most languages, or not declaring it at all if it's JavaScript, for example, you still have strong typing and type checking at compile time. And then you call this game method, or game loop method. And it's a method because you have your regular method parentheses at it with no parameters. So, as you can see, game loop's going to be returning us some Boolean truthy statement. And from there, you're going to get all right, I'm getting a true or false from my game. This is the only line that it should give you a compiler warning on, because we don't do anything with the result. It just stores there. In terms of how crazy this is, it's pretty formal once you get used to it. There are much crazier things you can do. For example, if I put a mut here, that changes quite drastically, but we'll get into that as we go down. So we have the function game loop. And that's where we jump into our game. So that'll be the second line called. So first we'll call the method. From there we jump into game loop. And this is where 90% of the heavy lifting occurs. So you got your game startup. And in most languages, here's your useful console output. So print line, except this one has a little exclamation point at the end. But be wary of that. If you don't include it, you'll get a compiler warning or actually an error, and it won't work. Welcome to Hangman with Dan. It outputs the line to the console. So now we encounter this mut, right? So that's mutable. So are you guys familiar with what like mutable strings versus immutable strings are in most languages? So if you are or aren't, what mutable means is once it's written to memory, it can be changed or it can't be. So mutable means you can change it, immutable means you can't. In languages like Java and C#, strings are immutable. So any operation you do to a string, with a few exceptions, creates a new string. So what this says is, give me a variable that can change, that I can reassign the value to. Otherwise, it's a fire and forget kind of thing. So in that first line, if I wanted to change that variable that just said, let, my variable without the mut, it would give me a compiler error if I tried to reassign to it later on. But, okay, so from there, I say, let's set up how many guesses we get. Here's the secret phrase of the game. Hello world. We'll see that in a bit. And then we create the Hangman string phrase. So this is our game setup right here. It's 3 actual lines, but they call it to methods that do a lot of the heavy lifting.
So all the variables are by default immutable?
Yes.
So all across the board, all there.
Yeah.
Okay.
And what's nice about it is if you try and assign to it, it will say, hey, you're trying to reassign to something that's already been assigned.
Okay.
What's nice is it kind of makes you conscious of your memory management implicitly. I like it because it makes you feel like you're more in control and makes you really cautious. Because one thing that Rust prides itself on is performance. So it's kind of implicitly making you be aware of your performance. So you can't just kind of say var here, var, and create all these extraneous variables. Well, instead, if you want to reuse something, they make you go the extra mile and put an extra 3 characters. At some point, it will just become second nature. But definitely while developing this, it'd be like build, it's gonna work, and it's like you're trying to reassign to something you can. But yeah, that's exactly it.
Okay.
So we have our setup. So set difficulty. Create our secret phrase and then create the string. So the display string is just our simple underscores that you would see. And then after that, we hop into our loop. So do you guys think I should go over kind of the whole skeleton once again, but with a little bit more implementation, or do you guys want to jump into the methods? Someone's going to have to make an executive decision.
Up to you guys.
Methods.
Okay, so jumping into the methods. So we have 3 methods or only 2 methods we're going to look at. So one is set difficulty, which returns how many guesses we get. So your standard Hangman when you'd be drawing the head and then the body and the legs. Obviously, sometimes you've played with a kid where you'll draw there's fingers on the hands and stuff like that. So that kind of lets you do that. And then there's the create Hangman string, which will take our phrase and then convert it into, kind of transcribe it into our hidden string. One thing that you could do is, if you got further on, you could form a struct that has the hidden string where it'll have an underscore, but then also store the hidden letter behind it. But this one, it's pretty simple, and I think most of you can do it. So first we'll look at the set difficulty. So as you can see, it allows the player to select their difficulty. So we're going off the screen a little bit, which I'll try and keep as much of it as I can on the screen. Okay. So what we have here is, it says fn set difficulty u32. So we're returning an unsigned 32-bit integer, so something positive from it, essentially. To, I believe 4 million is the number, if I know off the top.
Something like that.
Yeah. So we have let mut difficulty u32. So this is essentially our return variable, and I'm just declaring it ahead of time. As you see, I don't assign anything to it, so right now, by default, I assume it's 0.
Mm-hmm.
I don't know what they default to.
Yeah.
So right here we just have a standard loop, which is pretty cool. It's not a while, it's not a do while, it's not a for, it's just a standard loop, which is great. no condition. So this is kind of how you can do a do while, or this just says I want full control over, I'm going to break it in the middle somewhere. So print line, it says please select your difficulty. It runs off the screen, but 1 for easy, 2 for medium, 3 for hard. So we have our new variable. We want to accept something that can change. And then, so new string. So in most languages, it would say either you don't declare any type, or it would say new space type, open close parentheses as a constructor. This is how the constructor works in Rust. Constructor probably isn't the correct word. What would you call it?
Yeah, it's just a static function that makes a new one.
Sure. So it's.
But by convention, it's called new.
Sure. There we go. Yeah. So you can new up things.
New up things.
Sure. So that's your relation to the other one. So this is actually the one of 2 external library calls we make that you'll see right here. So if you see these double dots, these are actually just almost namespacing conventions, I'll call them. So in another language, that would be similar to saying system dot write line, for example, or system dot read key. That there are these library functions or library types. It's kind of namespacing convention. So right here, we have IO and then dot dot. So remember from the top of the code, we have this import system IO, which that's where this is coming from. That's that IO. I didn't have to declare it anywhere. It's essentially like a using statement almost in other languages. Standard in, so standard input, dot read line. The address of our difficulty input. So right here, as you can see, so the address, we're doing it by reference. We're not doing it by value. And then I have an expect statement over here. So off screen, the expect statement says if this fails, trying to store it in here, we're going to output it to the console. So it's cool because error handling and exception catching is kind of that. This is what in other languages you would want to wrap in a try catch, right? Because that would throw an exception, everything would blow up. It would be terrible. This, you just write it in line. It's taken care of. It's pretty cool, lightweight stuff. It saves a lot of lines of code that in other languages is pretty confusing to people that are new to it. Next, we use a match, which is kind of like a lightweight regex almost, except it has a couple more abilities that you'll hear and see in a second. So difficulty. So the same guy that we declared up here, we're going to match what we just read from the standard input, dot trim, dot parse, so call a couple methods on it that are attached to our string right here, so they're on the string type. So we are going to take the white space off of it, and then we're going to parse it. And then when we parse it, if it turns into a number, perfect. So if it parses in a number, we want that. Otherwise, continue. So it will loop back up. It's the standard continue that you'd see in any other loop. It would go to the top, and it'd say, please select your difficulty again, and we go through the process. So it'll forever loop them unless they put in a 1, 2, or a 3 for me. I'm sure there's cases where they can get around it. I didn't particularly put a ton of time into it. We're only worrying on the happy path. This is not CIA information they're hacking into.
I don't know.
Oh yeah, I mean that secret phrase might actually be.
Does it catch if they put like a 4 or anything?
Well, so that's what you're about to see here.
Oh, okay.
Right there.
So here's our manual actual business case rules. So that one will just catch if it's numeric. These are your standard conditionals. It could have been a switch statement if they support it. Do you know if they support it?
Matches your switch.
Okay, so actually what you just saw is a switch. So I could have also written this as a match. I was doing this quickly, so I just did if else chain together. If you have multiple cases, obviously you're going to want to use something that's more formal because this becomes really unreadable about where I got it. One more line and you're just being a meanie. So if it's greater than 3, it's too big. If it's less than 1, it's too small. Otherwise, we break out of our loop. So that's our terminating condition. So then, down below, we have the real, I'll call it beef of the method. So if they selected easy, we're going to give them, we're going to let them know they selected easy and they get 6 total guesses. So we'll return 6 to the flow. Otherwise 2 for medium, they get 4. Hard, they only get 2. And standard Hangman, if you guess it right, you don't lose a guess. If you guess wrong, you lose 1. So then that's that method. So then we come back up here. So then difficulty set. We have our secret phrase right here. And then we have our create Hangman string. So this one's kind of fun. Pretty simple, but fun at the same time. So one thing that you see is I have this thing that I call the phrase clone. And the reason I have the phrase clone is because I wanted to pass the string by value. So if I came back up here, you can see that I passed it .clone. I didn't pass it the actual variable. So one thing that has built into it is it makes it so it's very difficult to kind of set yourself up for failure. So since you can deal with a lot of references here, if you pass something in by reference and then you change it within the body of a method and don't return that value and then try and access it later, it actually gives you an error at compile time because it says, hey, you're messing around with this, but it's almost saying, are you sure you want to be doing that? We're not going to let you. We want you to make it very explicit that how you're interacting with it is in a very straight up and easy to follow way, and you're setting yourself up for success. So it has a lot of best practices built into the actual semantics of the language, which is cool.
Yeah.
So once we're actually in the method, I have a couple letters cut off, but that'll be okay. So create Hangman string. We return a string. We have our cloned phrase, so this is the phrase we had selected at the beginning of it. And then it's a copy. So notice this is a let, and notice this is a let nut. So this one we can't change, this one we can change. So we have our display string, so this is going to be what's getting displayed to the user. And then we have our regular phrase, which is the secret one. We new up our display string, and then we just use a simple for in. So for each, if you're in other languages, for in, you get the enumerator and you iterate over it. So what's interesting about this is you don't have indexing in your regular languages, or you don't have indexing in Rust like you have in your regular languages. So for example here, we say we want to iterate over cars, and then we say if our individual character does not equal a space, we want to append in an underscore. So your standard, just create the box that will hold that mystery letter. Otherwise, input the space. And then you just return it. So nothing fancy, nothing crazy. We're just transcribing it. So for every character that isn't a space, convert it into an underscore. And you might be telling yourself, well, what happens if it's some crazy character that is not an English letter? And that is 100% one way you can break it. So don't.
You know the secret?
Yeah. So if you want to break Dan's Hangman, you can go ahead and do it really easily. But anyways, so now we have our game set up, right? So we have our remaining guesses and we have our display string. So remaining guesses is how many chances do we have left to do it? Our display string is our kind of encoded or ciphertext, although it's not really ciphertext because it has no value behind it, as you'll see. And then we have our hidden phrase. So now we're ready to start our game. So we have a crazy loop, let me tell you. If you have guesses left and you haven't won, you keep playing forever. So as we had, what was that?
So remember to subtract from remaining guesses.
Oh, nah, we're good. Just if that's the case, just win.
Just one. Yeah.
So one thing is I have this external variable that's just is winner, so that's what's being evaluated. That's one of our terminating conditions. So that's our way to check outside of the loop so we don't keep redeclaring it. And then going back to our skeleton, so output our game state. We have our player guess. After they guess, we see if it's a match down here. If it's not a match, we handle that condition. And then finally, outside of the loop, that's game over, folks. And we write how they did. So it's nothing too fancy. We'll go back up to the top of the loop. Okay. See you later. I talked to you earlier.
When's the
Not
next
me.
one? Sorry.
A month
Next
from now.
month.
So
Month?
yeah.
Sometime.
You just do it once a month, right?
Yeah.
Alright,
Yeah,
I'll
we'll
be
see you
back.
then.
Cool.
All right.
Sorry to move early.
No, that's
problem.
fine. It's on GitHub, so if you want to look at it more, you can look at it
The
there.
video will go
And I know
up
the
too.
secret.
Yeah.
Yeah, exactly. Oh yeah, I mean, if you guys are ever playing Dan's Hangman out at a casino, and you make big bucks,
Hell.
yeah, exactly. Guess HELLO.
I think it's Jello.
Jello.
Oh no. All right, so output game state. So that's the first thing we do. Right as the game starts, you want to let the player know, hey, this is how many blank spaces this are. This is how many guesses you have. So what we do is we pass a clone of our string, because I'm lazy and don't want to pass by reference. I pass a value type, but a clone of it, of our remaining guesses, so how many guesses you have left, and then also a clone of the display string, which is the underscores. So we can go down that method. It's real simple. Let's see. So it's 2 lines. This is fairly similar syntax to if you've ever done C before when it comes to strings. So your print line, as we were using earlier. So you got a string literal here, but then you have your curly braces, which essentially say I want to pass an argument into it, and then comma, address to our string, and then we'll plop our value right in there. Nothing too fancy, nothing crazy. Nice, easy game. As you can see, guesses is a integer value, and display string is a string value, and both of those work just fine in the string, so you can pass them. There's nothing fancy about passing a string or a single character. They're just passing variables in as arguments. Coming back up to our loop. Oop. Up here, sorry, getting all lost. Okay. Lower. Oh no, I'm still up here. Oh my gosh. Getting lost in my own code. That's never happened before. Alright. So now we're going to have the player guess. So similar to the difficulty rating above, we'll declare a variable to store our results, and we want it to be mutable because this value will be changing, especially since it's in the loop. But even if it's any form of value, if you're doing any form of validation against it, where you're going to say, hey, you entered the wrong thing, it definitely has to be mutable, right? Because it's going to change. Using our IO package, we'll go ahead and read line, pass in whatever they input to our guess variable, and if it fails to input it into our string, it's going to output this to our console. So, good stuff, lets us know on the spot. Now, the only validation I do is down here, and this is much heavier than I was doing before, so you'll see I don't catch it right off the bat if they put it incorrectly, but I catch it a couple lines down. So then I want to get the single letter in, so they can put multiple characters in. I'm just going to strip off the first. I'm going to be using the game. It's really happy path coded. I'm not going to restrict the input to a single character somehow. I'm just going to say, hey, whatever you put in, let's hope it's a character. And then we handle it down here. So another mutable. So we say, all right, take our guess from up here, convert it to characters. So remember, we don't have indexing. So I can't just say guessed, brackets 0, as you would in other languages. And that's part of the UTF-8 part of it. I'm not going to explain it right now because it's immensely confusing, and they do a very good job of it online. But essentially, they support many languages, and you'll learn. Sometimes you'll be on like a forums or something like that, and you see some crazy like A, but it has like a smiley face in it somehow too. Well, UTF kind of allows you to combine characters to form other things. So the bytes that are behind representing that character, there can be multiple, sets of bytes that form one character. So it's not your traditional English character or your Spanish character. It's not a one-to-one mapping. You don't have one character and one value that represents it. So then, once you call .characters on it, well then it takes them and kind of boxes them for you. And then you say, I want the nth. So this says, give me the first thing. And then unwrap actually converts it to the character for me, or translates it, per se. So after all of this, I have the first character of my string. So that's one con of the language. I will say that. It's more difficult to do it. But it's also cool because now you don't need to worry about, well, what if someone that's Japanese wants to play my game? They can make guesses. They're not going to make very good guesses because this is meant for English players. But it's cool that it's built under the hood. It's fast. It's consistent. So localization and stuff like that, you don't need these special libraries to really help you. You could really easily just write it using this style. So now we'll get some of the validation parts of it. Warning, this is the most crazy line in the whole thing, and I'll explain it in a bit. But we have a nice little function that returns a Boolean that says, is it alphabetic? So that's nice. That's an English language support, which is nice. Or it's more of an ASCII support. So if it falls within a certain ASCII range, when it tries to convert it, it will pass. If it tries to convert it and it's one of those characters that's like a straight up UTF-8 that's very ranged, it'll just return false, which is nice. It won't throw an exception. It won't say, hey, this isn't English. It's not alphabetic, which is nice. So then we want to convert it to lowercase. So I thought I originally wrote a bug and I was like, oh, the first time I played it, it's not working. Well, it's because I made a capital H. So by default, if I put a capital H and I'm expecting a lowercase h in my comparison later, then obviously this will fail. So what do? I'm going to sit down for this one because it's something. All right, so on letter, most languages you could just call this and this would be perfect, right? You just say, give me the lowercase version of this. It'll just perform some cast. If it's, let's say ASCII, it'll just subtract the integer value and then convert it back into a character and you're like, perfect. Well, this returns an iterator with a single result. Great. That's not a character, so I can't use that. So then you have to call .collect on it, which captures the iterator value, but there's no direct support for just a character, so I have to collect it as a string. Okay, that's fine. Well, remember up here where we converted our string to a character, and we got the first value of it? So then I have to call all those too. So in order to get to convert one character to lowercase, and I'm sure there's a better way. Yale has already suggested one, but this is what I chained together. That works. It's 5 method calls. And it works great.
Perfect.
It converts my uppercase to lowercase, and it ensures that it's an alphabetic character, which is exactly what I want. And the best part is it's efficient, too. This certainly doesn't take 3 seconds to do the conversions. It's all very fast. So even though it looks like a lot of code, if you're used to like chaining in JavaScript or used to seeing crazy stuff like this, it's not terrible, but it's also kind of cool because it makes you think of, what are the results I'm getting and how do I actually interact with it. I'm sure as the language develops, people might create extensions or their own packages that make this much easier to work with. But as of right now, since it's new, there's going to be some things that aren't super fluid. And if all that fails, I tell you, hey, it's not a letter. And then we hit continue and it'll kick us back up to the top of our loop. So now for matching. And we're about to get into the coolest part, and one thing that Rust has that many other languages don't. So I have this up here that says found match. So essentially how I check for matches is I'm going to check our hidden string, and I'm going to iterate through that, given the character you input. So let's say I have hello world, and I input an H. Every instance of H, it's going to find. And what's cool is it's all done in here. So we're all familiar with a for each or a for in, depending on what language you're in, right? They're simple, they're straightforward. You say, for every character in string, for every item in a collection, do this. Do it to everything. But you have this guy right here, which is a tuple, right? So most of the time, you only get one thing you get to iterate across, or one thing you get to keep track of. But I have an I and a C. Well, I, that's normally an index, right, in a regular for loop. But C, well, that's my character, right? So this is cool, because it keeps track of the index I'm at, but it also keeps track of the value I'm interested in. So it's cool, because normally you'd have to write, a for loop with int I equals 0, I, less than length, continue. And then you declare this extra variable to hold it, or you create a for each and then create an integer to hold your index, right? They're like, well, you do that all the time. So let's go ahead and just work it right into the language. So now you use this tuple over your collection, and you can enumerate it, and you say, if my letter equals C, so our letter that we parsed up above, equals the character in the string. We found a match, and then we want to let the display string know. So this is cool because it says, hey, here's one of our iterator values, and then the index we get to use over here. So in the display string, I'll remove the underscore that we have at that index, and I'll replace it with the character index. There we go. Simple as that. That's pretty easy compared to converting a character to a string and back to a character. So this is actually really easy. It's in the documentation, easy to find. And that's the main bulk of it, right? So you input a letter, we'll iterate over the collection. It's very simple. It's not ciphertext, it's not encrypted. By no means is it super secure, it's just very blank underscores. Finally, at the end of the loop, if we found a match in that collection, so that truthy statement I set, or if we didn't find a match, sorry, we'll output wrong guess. Sorry, try again. We'll remove one of the remaining guesses. Otherwise, if we found a value, so it got updated in our display string, now we have to actually see, did the player win, right? So if you didn't have this in here, you'd win, but you'd still keep going forever. So that'd be terrible. So we have another win check, and then we say, let's pass our display string in, and by value type, and what it will do is a very simple function. And it just says, let's iterate over it again. Okay, winner check. So we pass in a string. It says for C, so you don't need to use a tuple. You don't need to keep track of your index. You can just have a regular iteration over a collection. Let's iterate over the characters of the string. If we find an underscore, that means we still have stuff to figure out. So you haven't won yet, break out of the loop, and then return the win check. Otherwise, if we don't find any underscores, return true. Simple, nothing crazy, nothing too fancy. So now we come back up to the end of our loop, and then we'll keep looping over that until they either run out of guesses or you win the game. Once you win the game, we have a little messaging at the end. So it says, you won, return true, or you lost, but here was the phrase you were going for. Now, if we want to run our game, you have to come to the command window, and it's very small, so I apologize for that. And so as you can see, cargo build will build your application. This is all covered in the guessing game tutorial. I really recommend doing that because they explain what's happening at each step. I don't want to botch it, so if you guys want to learn more about it, I really suggest going through there, and that will help you throughout the whole pulling something down from getting going and actually building it and running it. As you can see, I get one warning right here, and that's because in my original start game, I have an unused variable, which is cool. So it compiles, but it still has warnings like your regular languages to enforce best practices and make sure that your code's efficient. After that, I can say, oh, I don't have it right up front, but I have cargo run. So let's see. Oh gosh, can I actually zoom in on this? Do you guys know how to zoom in on? Oh god, it's trying to collect my input. Well, this is gonna be fun. It's really tiny. Would you guys like easy, medium, or hard that don't know the answer? You guys
Go
are
for hard.
Oh, hard. So I input 3. It says, all right, you get 2 total guesses, and you only have 2 guesses remaining. And it's hard to see from far away, but there are breaks in our little area. So what letter would we like to guess?
J. 'Cause
Exclamation point, you say.
it's Jello.
X.
Wrong.
Oh, wrong guess. We only have 1 guess remaining. Well,
I'll
what?
take an E for 500.
Sure.
E for 5.
Well, I'm gonna make it capital because I can. And when you input the capital, what's nice is down here, even though I input the capital, since we casted it to lowercase, it still accepts as an input and it doesn't register it as false. Well, what happens if I put in, I don't know, a space? Nothing. So it's resistant to this erroneous code you can put in. It doesn't penalize you. Well, what about if I put E in again? Oh, it doesn't penalize me, but it doesn't give me any more letters. So that's one thing that I didn't implement that would be great if you guys wanted to pull this down and add to it as a learning exercise. You can add a guesses that gets output to the console as well. So here's what you've tried. Here's with the state of the game. Here's what's left. So let's guess some more letters, guys.
Hello.
L-O? Well, remember, so I only took the first character, so you can't guess two at a time. It does pass.
I'm proving you correct, that's all.
I'm guessing out. What else?
Oh.
R.
We are. We already did
Do
it.
it again.
Oh, okay, we can do it again. Oh, we're still here. Is it Jello World or is it Hello World? That's the question.
Hello, Carl.
Is it Jello World?
Jello
Jello
World.
World.
It's definitely Jello World.
Oh, you lose! It was Hello World.
Oh man, I guessed that.
Oh, should have played on medium then. But as you can see, that the game's over. Once you reach the end of your main, it escapes like everything else. You don't need to do anything fancy. The game closes. If I wanted to, I could add a, hey, if you're, not done with it, hit space or something like that. A lot of C applications do that because when it starts, it opens up a command window. But since we're running this from command, it's there, it's maintained.
You say like add 50 cents for 2 more guesses.
Oh, yeah. Yeah, so actually there is a PayPal built right into it, yeah.
Okay.
Yeah, so it donates on your behalf. It sends it as a gift so you can't get it back. It's wonderful. But that's the game. It's nice and simple. It's a perfect difficulty for building on what you learned in the guessing game tutorial, but also kind of throwing you out, without the parachute, because you're going to get errors and you're going to have to scratch your head and you're going to have to work through them, but that's how you really learn, because you can follow a number of tutorials and really be like, oh yeah, this is so simple when they're holding your hand, but until you actually try and build something yourself and text your local Rust guru, hey, I'm getting exceptions and I don't understand them, Yale, please help me. I have a presentation later about this. But that's when you're going to really learn it, when you're forced into kind of the corner and you have to buckle down and learn it. But as you work with it, you learn that it's a really flexible language and it's really kind of easy to pick up, and a lot of stuff makes sense. So they don't do as much under the hood for you as other languages, but it's much more performant that way, and it kind of forces you to do best practices by default, which is also nice. But that's what I had. Does anyone have any questions?
Does Rust have like a built-in dictionary function? So say you have
Like the
Hello
data
World-
structure?
You have Hello World as default. What if you had like a dictionary of like 100 different ones and it randomly chose?
So that was actually originally what I was going to do, but I didn't have enough time. So I was going to create a side, because I know they have a random number generator right in there.
Mm-hmm.
So that would just be the other half. Instead of reading from the input, you'd just be reading from a file. So you'd say, if I first have a dictionary, right, that has, it doesn't have one, to the best of my knowledge, built into it.
Yeah, it's called hash set.
No, not a key value dictionary. He means an actual word dictionary.
No, I think you meant.
Well, I meant like dictionary of words. So not the true dictionary.
I mean,
but like a list or.
Yeah, Linux
like-
has one built into it, so you could use that one.
That's true.
But I'm not sure if Windows does. But the other part about Hangman is its phrases. So a dictionary won't really cut it. One thing that would be fun is if you made this and every time someone won, they had to like input some phrase. Granted, you get a lot of garbage in there, just like perfect.
Don't speak Arabic.
Right, but and then if it gets worldwide, you could start playing with Unicode, and it wouldn't break, but it wouldn't work well.
Yeah.
So that's the project. Yeah, I mean, I don't really have anything else to show. That there's definitely some things to build on. I mean, the biggest things that I learned while making this, the clone function, which works with most of the variable types that are already existing in there. You can clone almost anything. Super helpful with strings because of the couple trouble I ran into with the references, passing them around. You'll quickly learn, just clone it. That's kind of my way of circumventing their, hey, be really efficient with your strings, or just clone them and hide from the compiler. So knowing strings is really helpful here, but if you don't know them, this will kind of force you to learn them. And that's something that isn't as easy in other languages, but it's kind of nice because it really makes you understand, well, what is a string under the hood? I didn't make this with any handmade structs or objects in other languages. One easy thing you could do is instead of having that hidden text, you can just have a single phrase struct that has the hidden phrase and the underscores, and it has functions that can map to itself, so it's easier to work with, more modular. Another thing, ints don't exist. Well, they do, but it's not just int. You have to be more specific. I kind of like that because it forces you to, maybe I don't want an int, this time. Well, it's never going to be negative, so it kind of forces you to be more specific. And I always like when it makes you be more concrete than a little bit more flexible, because flexible is nice, but when it allows you to be lazy, then I don't really like it. The return type dash and then the let and the let mute are the other two things that you really learn from this. But other than that, that's all I have.
Cool.
So
Thanks, Dan.
you're welcome.
Was the networking portion also?